Phrase 6, question 1. It's a multiple choice. Question 1, according to the first law of thermodynamics, energy is not lost or credited, right? Energy cannot be credited or lost in any energy transformation. So your answer should be C. So A is being credited. D, energy is being destroyed. This is not right. Question 2, this is overall, this is question 1, this is multiple choice. So we have 4 questions. Question 2, in exosomic process, exosomic energy is released, right? So here I tell you, in exosomic process, heat is absorbed. True or false? Of course, false. Exosomic is energy release. Endosomic, absorb. Right, so this question, exosomic process, heat is absorbed. This is wrong. So you should choose B. Let's write it this way. So question 1, choose C, energy neither lost nor credit in any energy transformation. B, in exosomic process, heat is absorbed by system. This is wrong. Okay, you choose B. C, the work done on surrounding by expansion of gas against a constant external pressure is negative P times delta V. Is this true or false? William Scriber. So gas expansion against constant external pressure W always equal to negative P times delta V. This is a formula, right? This is always correct. So the choice is A. It's always correct. Always negative P times delta V. If this is actual expansion, delta V is positive. Final pressure, final volume greater than initial volume, then this work is negative because your system does work on surrounding. It's negative. If actual process is compressing, final pressure smaller than initial, delta V becomes negative. The negative is positive. That becomes surrounding does work on system. That is positive. Then question 4, an isolated system can exchange. What? No, nothing can change. Isolated system, neither energy nor mass or material can exchange. Open system can exchange energy and material with surrounding. Closed system can exchange only energy with surrounding. Isolated system, no energy, no material can exchange with surrounding. So you should choose B, D. Nothing can exchange. No energy, no material or mass can exchange with surrounding. this. Gonna see how later on. Okay. Then question 2. Start the question 2. You need to show work. I got it very clear. You need to show work for the rest of this question. For the reaction P4, react with oxygen gas produce P4O10 delta H negative 13 kilojoule per mole. 1. If 310 gram P4 reacted with excess oxygen, this excess, this means this is a limiting region. Of course, this must be limiting, otherwise this no meaning. That's the only limiting region you can use to calculate the product, right? So ask you how much heat will be released. Why released? Because this negative value tell you this is release heat, right? So this balance equation tell you every 1 more P4 react with excess oxygen will release this amount of heat. Then if 310 gram P4 react with excess oxygen, so clearly you need to convert this mass into mole first, right? Because this balance equation tells you every 1 more P4 produces this amount of energy. So 310, this is mass. Convert to mole. How to convert more? Mass divided by molar mass, right? I wrote in that corner many times. How can we get this molar mass? You need to use the periodic table. P molar mass is 30.97 gram per mole. But this is a molecular P4, so you need times 4. So this gram of P4 for every 1 mole. Okay, again, 30.97 from periodic table. The atomic mass times 4 becomes molecular mass, just like O2. O is 16. O2, then 16 times 2. Okay, here's the P4. So 30.97 times 4 is the molar mass of this molecular. So now becomes more. Then every 1 more P4 produces this amount of heat. Then just multiply by this number. Kilojoule per mole. And this per mole is per mole P4, right? So per mole P4 cancel this. And a gram cancel this, right? Left over is kilojoule. Your answer will be negative 74, 39.8. You can use 40, it's fine. Okay, 75, 40 is fine. Since this is negative, then second question is ask you the reaction is exothermic or endothermic. Negative is exothermic. Negative means release heat. Release heat is exothermic. I here tell you. So since delta H is negative, so this is exothermic process. Okay. Are you okay for this? If you're okay with this, then next. Question 3. For this reaction, 2SO2 react with O2 produce 2SO3. As you calculate this reactions enthalpy change from the standard enthalpy formation of each species listed in a table. I provide you a table. Okay, so calculate the reaction enthalpy from standard enthalpy formation. The general equation is total standard enthalpy formation from products. Here is products, right? 2 more SO3 minus total standard enthalpy formation from reactants. This is general formula. All right. Now we just use this case is product is 2 more SO3, so 2 times standard enthalpy formation of SO3 minus reactant, you have 2 reactants, 2 more SO2, so 2 times delta HF naught of SO2 plus new number means 1, so delta HF naught of O2. The rest you find standard enthalpy formation for SO3, SO2, and O2 from the table I provided to you. All right. So 2 times this is 395.2 for SO3. SO2 is negative 296.1. Oxygen has the most stable form of element N, oxygen. This is 0. So use calculator. You can easily get is negative 198.2 kilojoule. Okay, it's very straightforward. Are you okay? I can tell you we will have similar in the test. Really straightforward question. This is the almost the same as we learned in class. Okay. We have example shown in the class. Question 4 tell you specific heat of iron. Specific heat we use S is 0.444 joule per gram per Celsius degree. Ask you what is the final temperature if 554 joule of heat is absorbed. This is heat absorbed. Q by 78 gram. So this is mass. By 78 gram of iron bar initially at 25 degrees Celsius. This means this is initial temperature. Ask you what is the final temperature. Okay. So this is a physical process. Iron bar cools down. This cools down or heating. Let's see. Oh, this should be heating because absorb heat. 554 joule heat absorbed. So this temperature will goes up. Absorb heat, warm up. So absorb this amount of heat, and the temperature start from 25 up to where? Right. This is the question. So you need to think about the formula is this. Q equal to M times S times delta T. This is a formula. So this formula tells you heat absorbed or released depends on the temperature change, right? If temperature change is positive, this absorbed heat. If temperature change is negative, this is release heat. Okay, so both way you can use this formula. So now Q is 554 joule. M 78 gram. S is 0.444 joule per gram per Celsius degree. Okay. Delta T is a temperature change. Temperature change always final minus initial. Volume change also final minus initial. Pressure change also final minus initial. So any change, any quantity change, always a final value minus initial value, right? So final temperature minus initial temperature 25, right? So this both Celsius degree, initial temperature 25, final temperature you solve for this equation also Celsius degree. So Celsius degree consider this per degree. Per gram counts as a gram. Leftover joule, which is a joule from Q, right? This is a joule. So what you solve this TF from this equation is Celsius degree. Can you solve this equation? See, both, you multiply this first, right? Then both sides divided by this result. Then move this negative to this side. Becomes your final temperature. So final temperature should be 40.99 or 41. Or 41.0. They were here tell you initial temperature is 25.0. Then we kept one decimal place. So that's why 40.99 you can round up to 41. Okay. Is this complicated? This is actually pretty straightforward. The only thing is not exactly the same as the example we showed in the test in the class, but still this formula. In the example I showed in class, is tell you initial temperature, final temperature, mass together with S, also calculate Q. Now tell you everything else, just the TF. Actually, it's very similar. Unfortunately, this small change, many of you got lost. If you're going to take any chemistry test in the future, like graduate school, you have placement tests. MCAT also have some chemistry. Will not be exactly the same as we learned in the class. Same formula, but just ask a different parameter. You need to be able to figure out. Cannot be all example I showed in the class. We don't have so much time. As long as this formula we showed and you understand these parameters, then solve in one. So one equation you can solve one parameter. Most problem you lost is this last one. Okay, listen carefully. This is the last time you can learn. Some of you think how to learn actually lost. As you calculate the standard enthalpy formation of carbon disulfide from its element. So carbon disulfide from its element is this. Synthesize carbon disulfide from its element. Right? Synthesize this compound from its element. So this reaction's enthalpy change is standard enthalpy formation of this compound. Right? If I give you three related reactions, carbon react with oxygen, produce carbon dioxide. This reaction's enthalpy change gave to you negative 393.5 kilojoule. Second reaction is sulfur react with oxygen, produce sulfur dioxide, also give to you the enthalpy change. Unit is the same, kilojoule per mole. And the third reaction is CS2 react with 3 oxygen, produce carbon dioxide and 2 SO2. Negative 1073.6. So also you calculate the reaction force enthalpy change, because reaction force is synthesize this compound from its element. So this enthalpy change is this compound's standard enthalpy formation. Again, listen carefully. This is last time. I will not explain anymore because Monday is test day. Many of you get lost. Show the work nobody can understand. Show the work you don't need show, but the work you need show, then show. The strategy is build up this target equation from the 3 given equations, because 3 given equations, the enthalpy change is non-value, right? So we need to build up this equation from 3 given equations. This is the idea. So what I can build up this target equation from the 3 given equation, you just take a look at what we need. What do we need? We need a carbon. And take a look here. Which equation has carbon? Yes, equation 1 we have carbon. Right, so we get 1 carbon. Okay. For equation 1, we get 1 carbon. Then we need 2 sulfur. Which equation provides sulfur? Clearly equation 2. But equation 2 only provides you 1 sulfur. Then we just multiply by 2. So plus 2 times equation 2. We get 2 sulfur. Right. Then we need 1 CS2. CS2 only equation 3. But the equation 3 CS2 is a rectangle in the left side. We want this in the right side as a product. So what you can do is minus this, then we move to the right side is positive. Right. Minus equation 3. Minus equation 3, we move right side is this positive. Is what we need. So you may have a question. Even though from equation 1 we get 1 carbon, equation 2 we get 2 sulfur, equation 3 minus equation 3 we get 1 CS2, but in the same time we also introduce oxygen, we also introduce carbon dioxide and sulfur dioxide, and this we don't want. You may have this question, right? If you have this question, okay, up to now, we hope this formula give us equation 4. But you still have question is where this oxygen, carbon dioxide, and sulfur dioxide go? This is your question, right? If you have this question, we can work on the scratch paper. You can show me, but you need to show correct work. Okay. Some of you just show me This shot must be in scratch paper, but it didn't show me this. This is must show. Okay. Because of the rest will based on this. Okay, you must show this first. This is in scratch paper. Okay, just let you confirm. This formula give us equation 4. You don't have to show me. Okay. If you want, confirm by yourself. Work on scratch paper. Equation 1, let's work on left side. Or this equation, left side first. Okay. Equation 1, left side, C plus O2, right? Equation 2 times 2, again, left side. Equation 2 times 2, so 2S, 2O2. Then minus equation 3, minus CS2, minus 3 oxygen. We finish the left side. Now still use this formula. Work on the right side. Right side, CO2, equation 1. Two equation 2, 2SO2. Minus equation 3, again, right side. Okay. Also, all right side. So minus CO2, minus 2SO2. Right. We should both left and the right side according to this formula. Now we want to see if this gives us equation 4. If this gives us equation 4, we need to simplify. Define. I'll follow this one. CO2 answered. 2SO2 also answered. 1O2, 2O2 minus 3O2. Right. So now left over only couple right with 2 oxygen minus CSO2. Chemical reaction, chemical equation, normally no minus because A plus 2 means A react with 2. Produce C in the right side. So minus, we need to move to the right side. Right? So move to the right side and the left side. That's it, right? This move to the right side. And the right side initially is all cancelled. Only left over this. Is this equation 4? Yes, this is equation 4. So we confirmed this formula will give us equation 4. Again, this is the first step. You must show me this worth 2 points. Without this, you cannot go to next. Okay. Now from here, so equation 1, which give you delta H1. Equation 2, which give you delta H2. Equation 3, delta H3. The equation 4 is delta H4. And the delta H4 is the standard enthalpy formation of this compound. Alright, this is the next step from chemical equation to enthalpy change. Now you need to plug the number. Let's write this first. So delta H F of CS2 will be equal to delta H1. This negative 393.5. Delta H2 is negative 296.1. Delta H3 is negative 10 73.6. Use calculator, you can easily get the final answer is 87.9. Each step will worth some points. For this one, last step only 0.5. So find the answer on the 0.5, but you need to show each step. Step 1, this formula, where you come this formula. Step 2, replace this equation by the delta H. The step 3, plug in the number from here. The step 4 is the answer. Okay, if you just find the answer, you only made 0.5. Without should work, because I label here very clearly, must should work for this problem solving. Okay. Do you have any other question? Okay. If no question, then we get back